Hello. Good morning to everyone. I'm Dr.P.Ganesh from India. Today, in this class, what we are going to see is Introduction to DataLink Layer. So my earlier classes, which we all discussed about the fundamentals of computer networks, OSI reference model, TCP, IP, transmission media, and there are many physical layers we have discussed in detail. Now in this class, what we are going to discuss is the data link layer functionality, and also we are going to see that first initial section, what are all the major functions in how the data link layer, the data are going to be exchanged between one node to the another node, and how it is going to serve the services to the network layer, adjacent layers like network layer and the physical layers. And then we will be seeing about how link to link communication which is going to happen, and what is the addressing mechanism which is going to be used. These are all the things which we are going to discuss in this class. Introduction. So here we all know that the internet is interconnection of networks, so which is going to be a connection of multiple networks so that you can able to achieve an internet communication. So if you are going to our main purpose is to interconnecting a multiple networks, the purpose is going to be a data communication. The ultimate purpose is going to be, if you are going to connect from one network to the another network or one node to the another node, then ultimately our purpose is to exchange the data from one node to another node or one network to the another network. So if you are going to interconnecting a multiple networks, so which has to be done via the many internetworking devices, say for example switches, routers, and many other internetworking devices, which is going to be a connecting devices for networks. We all know the packets are which is going to be travel from one host to the another host via the multiple network. Sometimes it may travel the hundreds of networks also. So in this lecture, what we are going to see is how the communications are going to be happen at the data link layer. It means that how the data are going to be moved from one node to the another node. We all can recap, we can remember that in OSI and TCP IP model, we all know that the data link layer main functionality is responsible for data communication between one node to the another node. So here we will be discussing about how the communications are going to be happen at the data link layer from one node to the another node. So this may be the part of the LAN network, MAN network, and the WAN networks. So this will be happened via the connections of some routers. So if the host and routers all are going to be considered as a nodes here, because sometimes one node to the another node may be a one networking devices to the another networking devices. It does not mean that only the edge devices alone. It may be a edge devices, or it may be a any other internetworking devices also. So that is the reason. So the networks in between, we call it as an links. So we are going to discuss about what is a link, how the links are going to be, the data are moving from one link to the another link. That also we are going to discuss in detail. So what are all the major services which is going to provide according to the services, because this will have two adjacent layers. That adjacent layers are the network layer and the physical layer. So there are two options, two services it can able to do that. While it is transmitting, what it is going to do, while it is going to receive the data, what it is going to be done. While it is going to transmitting the data, it means that it receives the data from the network layer and it will do the process, and then which is going to forward it, which is going to provide the services to the physical layer while it is in a transmission. At the same time, in the receiving side, when it is going to receive it, the vice versa of the operations, like receiving the services from the physical layer, and which is going to provide the services to the provide the data to the network layer. Now let us see this diagram, which you can see that how the communications are going to be happened at the data link layer. You see that left hand side there is one end system is there, which has to be connected to some routers, or it may be some switches via some links. It means that one hop to the another hop delivery. So there will be a data communication, there will be a protocol which is going to involve in both in data link as well as a physical layer. And then if you see that from the B intermediate system to next to C intermediate system, it may travel, or sometimes it may travel to E intermediate systems. So what will happen is that is also one router to the another router is also going to be via one link. The same way, the links are going to be one node to the another node. So here from this you can clearly understood that one node to another node, it means that that node may be your end systems, or it may be your tablet or any other smart devices, whichever can able to do the process and send the data. And the second thing is that any other networking devices, it may be a switches, or it may be a routers, or it may be a routers also. So any kind of networking devices. So one node to the another node, which are all going to be by default, which is going to be considered as an link. So one link to the another link. So automatically, which is going to process the data from data link layer to physical layer, and then which is going to transmit the data to transmission medium. At the next node again, which is going to receive the data from the physical layer and then do the process in the data link layer. Then again it will process, and which is going to forward the packets to the next node. In this way, it can able to communicate from one node to the another node. Just for understanding purpose, here in this diagram which has been shown with what are all the layers which is going to involve from one node to the another node with respect to the data link layer. Now in this picture you can understand that which are all considered to be a nodes, which are all considered to be a link. Here we have considered that there are 6 links are going to be there. You see that there is one end system which is going to be a laptop. From the laptop, which is going to be via the LAN, which is going to be connected to one router or the switches. So that will be considered as a first node. And then one switch to the another switch, it may be a point-to-point network. So that will be considered as again one node. Whatever which is going to be shown as a dotted line, which will be considered as a wireless mode. So the earlier you can see that from the end system, left hand side end system to your router, which is going to be a wired link. So that will be shown as a thick line. So whichever it is shown as a dotted line, which is going to be a wireless communication medium. So likewise, so one link to the another link, it may be a heterogeneous in nature. It is not mandatory that there is only one type of communication medium alone has to be used in a single network. There may be a partial link, may be a wired, partial link may be a wireless also. This is what the nodes and links with respect to that data link layer. Now we can see that how a communication with only 3 nodes we will be considering it with respect to what are all the data which is going to be processed. You see that there is a one end system, left hand side there is one source, and in between there is another one router, and then right hand side you can see that is going to be a destination. So from the network layer, which is going to receive the data, the source station which is going to receive the data, and in the data link layer which is going to process it and which is going to forward it to the physical layer, then the data are going to be either it may be add or it may be a send via the cable. So that datagram which is going to send to one link to the next link. So once it receives, then it will receive the packet at the router and it is going to process it, and again which is going to be forwarded to the next destination nodes. This is how the communication which is going to happen at here. So whatever it is a actual link, and whichever it is shown as in dotted lines are going to be a logical link here. Now we will see that what are all the categories of links and the sub layers. So there are 2 ways it can able to do the communication. Either it may be a point-to-point link or it may be a broadcast link. So here in sometimes the IP address alone cannot be used to reach the destination point. In that cases, it requires some link addresses also. So sometimes the next link addresses may not be available. In that situation, it has to broadcast that information to identify that which is the next destination node. So in that point, the broadcast links are going to be very much it is useful. So the 2 ways the communications are going to be happen. One is in point-to-point link and another one is in broadcast link. So nodes are physically connected via the transmission media. That transmission media, it may be a wired or it may be a wireless in mode. So it can able to support for both the mediums. So ultimately, this data link layer which is going to controls the medium. If for example you can consider that if that particular mediums are going to be an wired medium. So in that cases, the data link layer has to control over on the channel. At the same time, if it is going to be a broadcast, the same time the data link layer which has to be taken as a control over the transmission medium. So there is a possibility sometimes the nodes may use either the full capacity of the medium, or sometimes it may be using as a partial usage of the capacity of the link. So the functionality and services which are all going to be divided, the entire data link layers are going to be divided into a logical link control sublayer and medium access control sublayer. So only the data link layer alone, which is going to be splitted into two sublayers that are all logical link control layer and medium access control sublayer, which is named as an LLC and MAC. So according to that functionality and services which are all going to be divided into two sublayers. Now let us see what is an addressing mechanism here. As we know that whenever the datagram or the packet wants to move from one node to the another node, it requires an address. So it requires an IP address, or that are all be normally name it as an identifiers at the network layer. But the thing is that the same IP addresses, that identifiers, which is not enough to reach the packet or the datagram to reach the exact node of the destination. It means that if you see that in intranetwork, if it mentioned as in a small I, that is going to be an intranet. So in that internetwork, the datagrams are not able to reach at the destination point with the help of only the IP addresses. In this situation, it must require some links address, as well as it may require some MAC addresses also. So this IP address define both the source and destination network addresses alone. It cannot define which links the packet has to pass through in it. So in this way only, sometimes it may be required to use the different types of addressing mechanism. The different types of addressing mechanisms are, one is an unicast and the multicast and broadcast mechanism. So this is a sample of MAC address, how the MAC address look alike. See how it is going to be identified. The networking devices are going to be identified. This address belongs to unicast, or this address belongs to multicast, or this address belongs to broadcast. For example, if all the addresses which are all going to be mentioned in F, if it is going to be mentioned as F, means it doesn't know that what is the next link, destination link address. So automatically, if any one particular node doesn't know about what is the next destination node, then immediately it will make it as a broadcast FFF. So automatically, so whichever the node is designated destination node, that node will receive that message, and which is going to respond to that the previous node. That is where the broadcast type addresses are going to be used. If it is going to be a unicast, that is going to be a one-to-one. If it is going to be a multicast, it may be a multiple nodes may be designated to receive. How it is going to identify is, if it is going to be a unicast address, if you see that the MAC address notation, the second letter, if it is going to be N, it means that the first 8 bits, so the second 4 bits of the data, if it is going to be an odd number, then the addresses belongs to an unicast address. If it belongs to an even number, then which has to be an multicast addressing mechanism. So these are all the 3 addressing mechanism which has to be used in the data link layer in a link layer addressing methodologies. Now we can see that how it is going to be worked out in the network. So the IP addresses and the link layer addresses in a small internet, which we are going to consider here. If you see that there is a one person, it's in Alice, and another one person which he may be seated in the Bob in a different location. This was a very good example which has been cited in that Ferozon data communication Ferozon book. The same thing which I've been explained it here. So the first node which is going to send an address N1 and L1, which is going to be forwarded to the next node. So here the N1 is an IP address, then the L, whichever it is noted as an, which is going to be an link layer addresses. So whenever it is going to be an N1 and L1, so automatically from the source node which is going to be reached to the designated the router or the networking devices. So once it reaches that particular point, that router then which is going to replace only the link layer addresses alone. So from one node to the another node, whenever it moves, there its IP addresses are going to be a static, which is going to be a constant. Only thing is that if you notice that from the source to the destination, so all the links which is going to be changed, the link addresses, first one is an L1 and then L2, L3, L4, likewise, which is going to use 8 different addresses up to that L8. This is how the IP addresses and link layer addresses, which are all going to be help the nodes to move the data from one node to the another node. See, for example, here how the data are going to be moved. Only that the link addresses which are all going to be changed till it reaches to that destination nodes. Now, so sometimes what will happen is that link addresses may not know by the previous nodes. In that cases, the address resolution protocol, which is going to help the nodes to move the data from one node to the another node. So that is where the address resolution protocol, that is ARP protocol, which is going to be used. So which is going to help the node, one node to the another node, which is going to send an IP datagram via the links. So IP addresses of the receiving nodes, which is going to receive it, and there is no use of the next node IP addresses, because which is going to be particular about that the link addresses alone. It need a link layer addresses of the next node alone. So that is where the address resolution protocol which is going to be useful. So where the ARP protocol which is going to be used in the network layer. So the network layer, we know that ICMP and IGMP protocol and IP protocol is there. ICMP is Internet Control Message Protocol, IGMP is Internet Group Message Protocol, and the Internet Protocol. So there the ARP protocol which is going to be used with the help of that IP address, which is going to identify the link layer address, and then that link layer address which is going to be added to that the data link layer. With that help, the data can move from one node to the another node. Now we can see that how ARP which is going to work. So take this example. Here you can see that the system A, which is looking for link layer address of a node with IP address N2. Say for example, I know the IP address of the receiving node. It may be a N2. So, but I don't know in which link which has been connected to that particular network. So I may be sending a request to the entire network by saying that who is having this N2 IP address. Simply I will request that I'm going to broadcast to all the nodes in that particular network. So whichever the node is holding that N2 IP address, that particular node immediately it can respond with that I am holding this N2 IP address. With that my link address is also L2. So that now the system A will understood that my destination, that N2 IP address system which has been connected to that network in the L2 link. So whatever the packets after that, whichever it is designated to that particular system B, then all the packets which is going to reach via that the same link. So this is how the ARP packet looks like. So here you can see that there are two important things. One is an hardware type, another one is a protocol. In this hardware type which is going to said about, that is what is an LAN and MAN which is going to specify, and the protocol type is what the data link layer protocol which is going to be used. So the hardware address length is going to be on 1 byte. The same way the protocol address length is going to be on 1 byte. And then the operation which is going to be a 2 bytes, either it may be a request or it may be the reply. So suppose the ARP, it is looking for an address, it may send a request. So whichever the node is giving a reply, which has to be included in the operation field as a reply. And then sender hardware address as well as a sender IP address, then the target IP address and the target IP address of which is going to have of 4 bytes of information. This is what the ARP packet look like. Now we can see that how the data are going to flow in a reality. So system AN1 which is connected to an link L1, and which is going to system B is going to reach, which has to be connected, which is having an IP address is N2 and the link address is L2. So whenever it goes, the ARP request which is going to first initially which is going to be broadcasted, so all it is going to be an zeros, then automatically which has to be understood that all the nodes which is going to receive that information, so whichever the node that is an N2 IP address which is held by the system B, only that address which is going to load that link addresses and it is sending reply to that system A. So this may be the point-to-point networking structure from one device to the another devices, from one network to the another network. So now we can see that how the packets are going to flow from one node to the another node. See, this is on one side, from the left hand side to the right hand side. If it is going to be a point-to-point network, it may be connected to one router to the another router. So it is a very easiest way you can understand that. From the network layer, what it is going to do is the network layer which consists of an ARP protocol, because this will happen a forwarding table. So with that help of forwarding table, ARP protocol which is going to send a request to that all the nodes. So whichever the nodes is having that particular IP address with that link which is going to respond with that, then the data link layer which is going to store all that information, and after that information which is going to be passed on to a physical layer which is going to be sent via the transmission medium. So now the flow of activities at router R1. So in that R1, how it is going to happen? So in that R1, when it is going to be sent, so it will reach in that network layer. When it is going to receive, the physical layer will come, and then it will move on to that data link layer which will have both 2 IP addresses and 2 link addresses. Then the data link layer process it and it will send it to a network layer. When it comes, the data comes from the network layer, first it will ARP protocol which is going to identify which is the node, then with the help of ARP protocol, then once the link is identified, after the network layer, once it comes to a data link layer, both the IP addresses as well as the link addresses which is going to be added along with our data, then that data which is going to move on to a physical layer and which is going to be sent to an R2. Now at the receiving side in R2, how the packets are going to be received. So when it receives the physical layer, it is going to receive, then it will see the link and then it will process it and it will send to a network layer. In that network layer, with the help of ARP which is going to identify the same process which is going to be repeated at this end, and finally this system B which can able to receive that information. So what are all the activities which is going to be happened at that receiving side? So at the physical layer which is going to receive the data, and then data link layer which receives that both the 2 IP addresses as well as that 2 link addresses, and then the data which is going to be link addresses which is going to be removed, and then which is forwarded to that network layer. From the network layer, by seeing that addresses, and then it will move on to a transport layer by seeing that what is a port address, it can identify this data belongs to what process it belongs to that. So reassembly process, reassembling all the packets. Once it reassembles, the original information can be retrieved. That information can be moved on to an application layer to make it visible to that receiver system. So I hope you understood the link layer addressing as well as the data link layer functionalities. Let me recap that. So initially what we have discussed is, so what is the use of that data link layer? What is the responsibility? This responsibility of moving data from one node to the another node alone. So it is not by using only the IP addresses alone cannot reach that entire destination. So instead of that, we required some more addresses. That is where we required some link addresses. To identify the link addresses, we have to understood that what are all the types of links are available, what are all the broadcast mechanism, what are all the addressing mechanism which is used in that protocols. There are three types of addressing mechanism which is used in here. That is an unicast addressing, broadcast addressing, as well as a multicast addressing. From that MAC address, we can understood that how the unicast address, how the multicast address, and how the broadcast address. If it is going to be a broadcast address, mean FFF, it's going to be there. So if that particular node doesn't know about the link addresses, how it is going to identify? With that help of address resolution protocol. That address resolution protocol which is there in that network layer. So we have discussed about how the address resolution protocol able to identify the link addresses. Based on that, it is going to move the data to the correct destination. So that we have discussed how the address resolution, it is in a broadcast mechanism to identify that, and then it will forward the data. And then we discussed about in each and every router, each and every devices, what are all the process which is going to involve, from the physical layer to the data link layer, from the data link layer to the network, the same way the network to data link to physical layer, how the original information can be reached at that receiver side. I hope you understand the concept very well. So if you have any doubts, you just give it in the comment line. I'm happy to respond to your questions. If you don't subscribe to my channel, please subscribe to my channel to regularly watching my videos related to ICT technologies. Thank you. Have a good day.